Friends, for years, astronomers believed that the long span of red dwarf stars made their orbiting exoplanets prime candidates for advanced life. However, the groundbreaking new research is challenging this assumption, suggesting that a combination of factors from interstellar flares and the tidal locking to the spectral energy distribution makes development of the complex advanced extraterrestrial civilizations highly improbable around these common stars, which are the M star or the red dwarf stars. Let us explore this point further. Hello, space explorers and the fellow cosmic dreamers. Look up at the night sky tonight and you are looking back in time, gazing at the countless suns, each a potential home to planets and perhaps to life. For generations, the idea of extraterrestrial life, especially advanced civilizations, have captivated us. From science fiction epics to dedicated scientific endeavors like SETI, the questions are: we alone? Echoes through the collective consciousness. And for a long time, our particular type of stars, the humble red dwarf or the M dwarf, has been seen as our best bet for finding life. They are by far the most common stars in our galaxy, long-lived and seemingly stable. And the logic suggested that more stars, that means more planets, more time, more life. But if that logic is flawed, what if the very characteristic that make red dwarfs seem so promising are actually their biggest downfall when it comes to fostering advanced civilizations? Let's set the scene. Imagine our sun. It's a G-type star and it has a lifespan of about 10 billion years. That's plenty of time for life to evolve from single-celled organisms to complex intelligent beings like us. But red dwarfs, that's a big question mark. They burn their fuel so slowly that their lifespan can stretch for trillions of years, far longer than the current age of the universe itself. This incredible longevity makes them seems like the ultimate cradle for evolution, offering an almost infinite timelines for life to adapt and flourish. They also represent about 75% of the stars in the Milky Way. That is a staggering number, and because they are so dim, their habitable zones, the region where the planet can have liquid water, are incredibly close to the star. This means planets are often tidally locked, presenting one face perpetually to the star, like our moon to Earth. Sounds idyllic, right? A warm, consistent environment for eons. The sheer numbers of these immense timescales, the seemingly stable warmth, it all painted a very optimistic picture for advanced life thriving around the red dwarf. But the science is about continually questioning assumptions, even the most appealing ones. And the recent groundbreaking research is forcing us to consider the red dwarf's role in hosting advanced civilizations. This isn't just about whether simple microbial life can exist. That even that's still very much an open question, and perhaps even likely it's a big question. This is about the leap from pond scum to space-faring societies. The leap to technology, complex ecosystem, and abstract thought. And what this new research suggests is that the conditions around red dwarf, while potentially nurturing basic life, might actively hinder or even prevent the evolution of anything truly advanced. We're talking about red dwarf dead end for advanced civilizations, and therefore let's explore this further. One of the most significant challenges come from the stellar flare. While our sun has flares, red dwarfs are notoriously, for them, especially in their early lives, they are often far more active and volatile than sun-like star. These flares are colossal bursts of radiation, which includes X-rays, gamma rays, charged particle ejected from the star's surface. And remember how these close habitable zone planets orbit these stars, so the planets are very close. This proximity means that the planets in the habitable zones are constantly bombarded by these super flares. A single powerful flare that could strip away an entire planetary atmosphere in relatively short order. Without an atmosphere, liquid water evaporates and the planet's surface becomes exposed to deadly radiation. Even if an atmosphere somehow reforms, it would be constant battle against repeated assaults. For advanced life, an atmosphere isn't just for breathing, it is a shield, a climate regulator, and a reservoir for vital elements. Imagine trying to evolve complex biochemistry, let alone build complex structures in an environment constantly being sterilized and stripped bare by radiation storms. It is not impossible for some life to adapt, perhaps underground or in deep oceans, but for surface dwelling, technologically inclined life, it becomes almost insurmountable hurdle. Next, let's talk about the tidal locking. As we mentioned, because the habitable zones are so close to the red dwarf, planets in these zones are very likely to become tidally locked. This means one side of the planet permanently faces the star. That means one side will always have day and the other side will always have night. So experience eternal daylight while the other faces the perpetual darkness. At the first glance, this might seem stable, but the reality is far more extreme. The day side could be scorching desert, boiling off any surface water. The night side would be frozen wasteland, trapping all its water as ice. Between these two extremes lies a narrow terminator zone, a twilight strip where temperature might be moderate enough for liquid water to exist. But even here, life would face immense challenges. Tidal locking often leads to extreme weather patterns, with super hurricane force wind constantly roaring from hot day side to the cold night side, trying to equalize the immense temperature difference. This isn't just a strong breeze, it's a constant global gale that would make Earth's strongest storm look like a gentle whisper. How does the complex, delicate life evolve? Let alone build civilizations in such a brutal environment and climate. It's a big question. The consistent, predictable seasons and weather patterns will take for granted on Earth are crucial for stable agriculture cycles, resource management, and the very development of complex societies. Now, let's consider the light itself. Red dwarf emit most of its energy in the infrared part of the spectrum. Unlike our sun, which peaks in visible light, this might not seems like a big deal, but it has a profound implications for life. The photosynthesis, the engine of almost all life on Earth, relies on the visible light, while life could theoretically evolve to photosynthesis using infrared light as well. It's less efficient process. Terrestrial plants use chlorophyll, which absorbs visible light very effectively. Life adapt to infrared would need different pigment and the energy yield might be lower, potentially impacting the overall productivity of the ecosystem. A less efficient energy source at the base of the food chain could mean less biomass, smaller ecosystems, and a harder time supporting large energy intensive organisms, exactly the kind that often characterized as advanced life. Imagine trying to build a complex brain which consumes a huge amount of energy in an environment where energy is always at a premium. This isn't a definitive no, but this adds another layer of difficulty to the evolution of the complex and advanced life forms. Let's also consider the formation period. Red dwarfs in their youth are often even more active and flare prone than in their stable middle ages. Planets forming around them would endure an even more brutal bombardment of radiation and stellar winds. This stellar adolescence could effectively sterilize a nascent planet multiple times over before conditions even began to stabilize. Our own Earth experienced significant geological and atmospheric changes, but within a relatively consistent range that allowed life to take hold and gradually diversify. For a red dwarf planet, the early conditions might be so relentless, harsh that the window for small life to get foothold, let alone diversify into something complex, might be incredibly narrow, if it exists at all. The constant disruption could prevent the long, uninterrupted periods of stability needed for life to become truly, successful. It is important to clarify that what we mean by advanced life. We are not just talking about the extremophile in the subsurface ocean. We are talking about life that can build, manipulate its environment, communicate complex ideas, and ultimately wonder about the stars. For this, you typically need few things. Number one, stable, diverse ecosystem. Two, predictable environmental conditions. Access to diverse resources. A suitable energy source. Long period of relative calm. And therefore, these are very, very important. On Earth, our path to advanced civilization relied on a stable atmosphere, moderate temperatures, a strong magnetic field, a liquid water ocean, and cycle of seasons that allowed agriculture and resource management. We had fire, tools, and the ability to look up without fear of being instantly fried by a solar superflare. These aren't just luxuries, they are the fundamental prerequisite for civilizations to emerge from mere biology. So what does this new understanding of the red dwarf mean for our research for alien life and the famous Fermi paradox, the contradiction between high probability of extraterrestrial civilizations existence and the lack of evidence for them? If the red dwarf, the most common type of stars, are essentially a biological dead end for the advanced life, it significantly reduces the number of potential locations in our galaxy where we might find beings capable of building radio telescopes or even spaceships. It doesn't mean life is rare overall, but it severely limits the number of places where intelligent technological life could evolve. This gives us a partial, sobering answer to the Fermi paradox. Perhaps this silence isn't because no one is out there, but because fewer advanced civilizations ever get off the ground, even in seemingly ideal cosmic conditions. Our focus might need to shift even more towards sun-like stars, which, while fewer in numbers, might offer more stable and benign environment truly necessary for long uninterrupted evolutionary path to complex and intelligence. Uh, of course, science is never truly settled. There are always unknowns. Could there be a form of advanced life that evolved entirely differently? Life that doesn't need a stable surface, or that thrives in subterranean oceans bound by the geothermal vents, shielded by the stellar flares. Perhaps a civilization could exist deep within the tidally locked planet's crust, never seeing its star, but still developing technology. It's a tantalizing thought, but such scenarios present their own extreme challenges for observation and even for basic resource acquisition. And while fascinating, they are perhaps even more speculative than the idea of surface dwelling civilizations. For now, based on our current understanding of physics, chemistry, and biology, the red dwarf system presents a formidable barrier to emergence of highly complex technological societies. Zoom back out to Earth, then to our solar system, then to our place in the Milky Way. Emphasis on Earth is quite unique. This new research, rather than dampening our spirit, should sharpen our focus. It suggests that Earth and our solar system might be even more uniquely fortunate than we previously imagined. The conditions that allow us to evolve, a stable sun, a planetary magnetic field, a large moon to stabilize our axial tilt, a protective gas giant like Jupiter, these might be far rarer and more precious than we previously thought. It shifts our perspective from life is everywhere to advanced life is truly a cosmic lottery win. And that makes the discovery of any life, simple or complex, all the more profound. It reminds us that our quest to understand the universe is ongoing, full of surprises, and constantly refining our place within a grand cosmic tapestry. The silence of the universe might not be an empty void, but a testament to the immense challenges of the existence itself. So, friends, what do you think about the red dwarf dead end? Does this research change your perspective on alien life? Let me know your thoughts in the comments below. And if you found this journey through the cosmos thought provoking, please hit that like button, share this video with your fellow stargazers, and don't forget to subscribe for more deep dive into the mysteries of the universe. Your support helps us continue to explore the most fascinating question in science. Thank you for joining live, and thank you for watching. Until next time, please keep looking up and exploring.